Hello everyone, today I'm going to tell you about the technologies that I used in the project. First is Node.js. Now Node.js is an open source cross-platform runtime environment that allows developers to build server-side and network applications using JavaScript. Unlike traditional JavaScript, which runs in the browser, Node.js runs in the server. It uses V8 JavaScript engine from Google Chrome, which compiles JavaScript directly to machine code, making it fast and efficient. Some of the key features of Node.js is that it is asynchronous and event-driven. It means that Node.js operates on a non-blocking IO model and it doesn't wait for the task to finish before it's starting new ones. Now, another feature of Node.js is that it is a single-threaded but scalable environment. Although Node.js operates on single thread, it is designed to handle multiple connections at once thanks to event looping. Another feature of the Node.js is the NPM Node Package Manager. Node.js comes with the world's largest ecosystem of open source libraries through NPM. This allows developers to easily share and manage and reuse code cross-platform. It works on Windows, macOS, Linux, making it versatile and adaptable to various development environments. The reason Node.js is used here because it is easily integrated with the API that we have used here for PDF extraction. Another feature of Node.js it is the full stack JavaScript. With Node.js on the backend and JavaScript on the front end, developers can use a single programming language across the entire web stack, simplifying the development. The use cases of the Node.js is web applications, popular for building scalable web applications, API services, great for creating RESTful APIs, real-time applications, ideal for chat applications, live update, etc., and IoT. Internet of Things. Node.js is lightweight and efficient, making it suitable for large volumes of requests in IoT systems. The way to download the Node.js, as you can see here, is the site nodejs.org, and here we can download the Node.js, or you can also go to the downloads here and install the Node.js according to the system you are on and using any package manager that you want. I use the FNM here and install the latest version of the Node.js. This is also the commands that you can run from the terminal to install the Node.js. Now, popular frameworks that are built on Node.js are Express.js, Nest.js, Socket.js. Now let's come to the PDF extraction. This API was taken because it easily extracts the data from the PDF and can convert it into a zip file. We use the unzip in our code, unzip the file and show the data on the front end. But this is a powerful API that can convert the PDF data into the JSON format, and that JSON format can be used on the front end. Now, Adobe PDF Extract API is a cloud-based service provided by Adobe that allows developers to programmatically extract and analyze content from PDF documents. It offers powerful way to process and retrieve structured data, text, tables, images from PDFs, making it easier to work with unstructured data. Key features of Adobe PDF Extract API is text extraction. The API allows you to extract all text content from PDF documents. It retrieves the text while preserving the reading order, which is essential for analyzing and processing information from complex documents. Table extraction. The API is capable of recognizing and extracting tabular data from PDFs, converting it to structured formats like JSON. Image extraction. Extract images embedded within the PDF files, enabling developers to work with visual elements of the document. Structured data extraction. One of the most powerful aspects of this API is its ability to convert the unstructured contents in the PDF into structured data formats like JSON, XML, and CSV. This allows the integration with databases and other data processing workflows. Layout and styling information. The API retains metadata about the layout, font sizes, and formatting of the document. This can be important for understanding document structure, recreating layouts, or ensuring that extracted content maintains its original content. Output formats of this API is CSV, for extracting tabular data, JSON for structured data like text, layout, styles, tables, and images. Use cases is data extraction from reports, content analysis, document conversion, automated document processing. Integration and the workflow of this API is API access, Adobe IO Console, SDKs, and post-processing. The benefits of using this LOPDF extract API would be time efficiency, accuracy, scalability, and customization. The common applications, it is used in financial services, legal industry, healthcare, and e-commerce. Thank you.
Hello everyone. Today I'm going to share with you a code that is going to convert a timetable that is given as an input and then tell the workload that the particular teacher faces throughout the week. So this runs in a way that first we input a PDF that is a timetable of a school or college as per your need, and then it tells you the load that the teacher faces throughout the week. So first I'm going to start with the So yes, first I'm going to start with a basic introduction about the Express. Now Express is a popular open source web framework application for Node.js, a JavaScript runtime that allows developers to build scalable, high performance server side applications. It also provides a wide range of features and utilities for web application development, such as routing, middleware, and template rendering. With ExpressJS, developers can quickly create server-side applications that handle HTTP requests, process data, and respond with dynamic content or data from the database. It also supports a wide range of middleware that can be used to add functionality, such as authentication, compression, logging, and ExpressJS is designed to be flexible and easy to use, allowing developers to customize and extend it to meet the specific needs of their application. Its modular structure and extensive community support make it one of the most popular frameworks for developing web applications with Node.js. Express is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications. Now that I have given you a basic introduction of Express.js, I am now going to explain you the code that I have written here. First, we are going to start with the server-side code. The server-side code, which is also known as the backend code, is written in this file known as server.js. First of all, in this, I have done the imports that you can see here, the Express, Mutter, app, and also the course. Now, explaining the Express import. Express, as I have said, is a fast and minimalistic web framework for Node.js, and it is widely used to build server-side APIs and applications. It also simplifies the process of creating HTTP endpoints and handling requests and building RESTful APIs. Now, the import that you can see here, const mutter, it is a middleware for handling multi-part form data, which is primarily used for file uploads. Since this is the application where I upload a file and it tells the workload of a particular teacher, therefore the file uploads are done through the Mutter. Now, this Mutter allows us to upload PDF files from the client to the server, where they are temporarily stored before processing. Now, the course import that you can see here is a security feature that is implemented in browsers that restrict the applications running at one origin, thus making. Now, as I was telling you about Course is a security feature implemented in browsers that restrict the web applications running at one origin domain from making requests to another domain. This is important when the frontend and backend are hosted on different domains. Thus, the integration of frontend and backend of different ports is done through course. Now, we configure the course here. We allow the request from a specific port that you can see here. The frontend is running on 5500 port. Therefore, we are allowing the course configuration from the frontend 5500 port. Now, the other import that you can see here is the .env .env is a zero dependency module that loads the environment variable from a .env file into process.env. Here you can see this is the .env file. Therefore, to load it, we use the required .env configuration. Now, this is essential for securely storing sensitive information such as API keys, which in this case includes Adobe's credentials. The two credentials that you can see here are the Adobe Client ID and Adobe Client Secret. Now, the API used in this code is Adobe PDF Service Node SDK. This allows for the import. The credentials used are here in the code in the post endpoint of the extract text. Now, this API allows the interaction with Adobe's cloud services, such as converting PDFs, extracting content, and more. In this demo, the SDK is used to upload a PDF, extract its textual content, and return the result as a JSON object. This service principal credentials are used to authenticate with Adobe Service. Therefore, for connecting with the Adobe API, these credentials are necessary. Extract PDF job creates a new job to extract text from uploaded PDF, and the extracted text is returned in the form of JSON structure. Now, here another Atom zip import is a library used to handle the zip files in Node.js. After the PDF content is extracted, the result is returned in a compressed zip file format. We use ADM-zip to extract the JSON data from this file. Now, another import that you can see here is const fs is equals to require fs. This is a file system that we are importing here. The fs module in Node.js provides an API for interacting with file system. It's used here to handle file readings and writings, including creating streams to read, upload files, and managing the results of the PDF extraction. Now let's go to the detailed code walkthrough. The Express.js setup, as I've already explained, is done through these imports. Now we set up the cores here, and we are allowing the configuration from the front-end port of 5500. Now the file uploading using Malta, the import is done here, and the const upload is equals to Malta. This is where the file that we are getting from the front end is uploaded to the backend. Now the text extraction from the PDF is done through the endpoint, that is app.post, and this is the extract text endpoint by which it converts the PDF file that we have gotten from the front end and gives a JSON response. This endpoint handles a request. Here, as you can see, I've done the error check. If the required file is not present, it says the no file uploaded. I've also added the console.log checks that uploads the response of whether we have gotten the file or not. Now, since we use the Adobe PDF services to upload the PDF and extract text, these are the credentials that are used to authenticate whether we are using the right Adobe service or not. Now, the const PDF service here, as you can see, is authenticating with the credentials. Here, the read stream is creating a read stream of the input file, and it is also taking out the request.file.path as an input. Now, here the extracting data and frequencies are done by the const params is equals to new extract PDF params. It is extracting the PDF params that was given from the PDF and from the front end. After the extraction, the text is analyzed for occurrences of specific initials. The initials are the teacher's name that are being searched for in the input PDF. Therefore, the extracted text given here is used to extract the occurrence of the initials. Now the extracted text is filtered, and as you can see, we have created a write stream, and here we have done the filtering of the extracted text here, and then we have mapped the extracted text. The calculate frequencies function that I'm going to show you later calculates the frequencies from the extracted text that tells us the load of the teachers, and then in the initials of the extracted text. Now sending the response. Once the extraction and frequency analysis are completed, the result is sent back to the client. This result is sent in the form of response.json extracted text frequencies. Now the file cleanup. FS here, the gut frequencies endpoint is through which we can actually print the load of the teachers in the front end. It is printed in the form of a table. Now, this is the create output file. Now, the get endpoint is for extracting the frequencies. So, in conclusion, this script demonstrates how to build a file upload API with text extraction and frequency analysis using Node.js, Express.js, and various libraries. Adobe PDF Service plays a key role in extracting structured text from PDFs, while Miter and Course handles the PDF file uploads and cross-origin communications. Now, this was the server.js code explanation. Now we are going to go for the dependencies that are downloaded. These are shown in the packet.json file. All the downloads that we have done, like the Axios that is used to communicate from front end to the back end. This is imported and we can see the version here. The course is also integral for handling the security checks when we are communicating from front end to back end. .env, as I've already explained, is necessary when we need to communicate with the .env file that contains the security features and the credentials that are important and do not need to be disclosed to the public. Express, as you can see, is being downloaded and the version is being mentioned here. Miter is responsible for the PDF file uploads. Unzipper is necessary to unzip the file. As we can see, the Adobe PDF client service actually gives the JSON output in a zipped file. For the unzipping of that zipped file, we have downloaded the unzipper here. Now, we are going to come to the front end code. The front end is where the actual application that we see from the user side is written here. Now, the code is basically written in the HTML, CSS, and JS. This is the HTML part, and in this, I have included the CSS here. As you can see, the CSS can be shown with the headings in the yellow color. And the JS code, this is the HTML code. This actually is shown on the front end side where we upload the PDF and then fetch the frequencies. JS code is integral for communicating with the backend. Therefore, the JS code written here is written communicating with the upload button. The upload button then gives the call to the backend. It's not necessary to understand the whole flow of the code here. I am going to explain it in detail line by line. And this is where the HTML code ends. Now, first, we are going to the provided HTML, CSS, and JavaScript code creates a web page that allows users to upload a PDF file and then display the frequencies of some data, likely extracted text or specific data set in a table. The technologies used in this code include basic web technologies like HTML, CSS, and JavaScript, along with Fetch API for making HTTP requests. Below is a detailed explanation of each part. The technologies used first is the HTML. It is also known as Hypertext Markup Language. HTML structure the contents of the web page. It defines the elements like buttons, files, inputs, tables, divs to organize and display content. CSS, also known as Cascading Style Sheets. CSS is used to style the web page, control layout, color schemes, and responsiveness. JavaScript adds the interactivity to the web page. It handles events like button clicks, file uploads, and fetch data from the API. Fetch API is a modern browser-based API that is used for making HTTP requests. In this code, it is used to upload the PDF and retrieve the frequency data from the server. Form Data API. Form data is used to handle the file uploads. It allows appending the selected files to the form data object before sending it via the fetch API. Flexbox CSS. CSS Flexbox is used for creating a flexible layout, aligning elements in a container, and managing responsive designs. Responsive design is so that it can work on different screen sizes. Detailed explanation code. First, we are going to start with the first 5 lines. The HTML provides the basic structure of the web page. The meta tag specifies the character encoding as UTF-8 and ensures the page is mobile friendly by using the viewport tag. The title of the web page is set to frequency display. CSS styling. The styles are included in the style tag as you can see here. The style tag, first, this is the whole body style that is mentioned in the star. The body style is mentioned in the body, and these are the font family. The line height specified is 1.6. Color can be chosen from a variety of structures. Display is flex. The flex direction I have kept as column, and the align items as center. A padding is the overall difference that we are given from this side of the screens. That is 20 pixels is being given from the left, right, top, and bottom of the screen of your laptop. Now, the global reset, as you can see here, style is to ensure that all elements set to use the border box model, making layout management easier. It removes any default margins and paddings. Body styling, the background is set to dark color that is specified here, and also the text is the light gray color. As you can see here, the color is specified as light gray. The FlexWasp model is used to center the contents horizontally and align the items vertically. The table styling is given here in the frequency table. The margin given is 20 pixels and auto. The width is 50%. The border collapse is on with the collapse feature, and the box shadow given is 10 pixels, and the color is mentioned here. Again, you can choose the color from a variety of feature that is open here. Now, the frequency tables, this is the frequency table heading, and this is the frequency table content. TD is the content of the frequency table, and TH is the heading. Now, the spinner is need to be the spinner class is not included here. I have made the CSS for the spinner. Therefore, the spinner styling, as you can see here, the position is fixed. The top is 50% from the screen and 50% from the left. I've also done a transition. Therefore, the transition mentioned here is transform, translate -50% to -50%. Therefore, when the spinner is loading, the position changes. The background color, as you can see, is specified here. The padding given here. The border radius is 10 pixels, thus giving it a circular structure. The color of the spinner is kept white. The display is flex. The items are aligned at center. I've done the justify content and the Z index that keeps the track of all the contents that are entered in the fretted. Therefore, the Z index kept as 1000 means that it is at the front end of the page. This is the further styling of the spinner class. The spinner appears at the center of the screen while data is being processed. It is styled with the semi-transparent black background and circular due to the border radius 50%. The spinning animation is achieved while the keyframe rule spin. As you can see, the keyframe is given here. Now the input and button styling. As you can see, this is the button styling and this is the input. First, we'll go with the button styling. I have done the background color as blue. This is up to you and what you feel is the best for your front-end structure. Here, the main important thing is the transition that I have added here. In case I click on the button, it would be an ease in and ease out where the background color changes. Now, the buttons are on hovering, the background color of the above button would change to this color. This is specified from the transition given here. This is an interesting property of CSS that is used to gain more user interaction. Buttons are styled as I've already shown here with the given color. Now, the input type is file. This is where it is connected to the HTML structure that is given below. This is where I'm inputting the file and the CSS for it is given here. Now the input type is file and the padding, font size, margin bottom is up to the person. and the background color I've kept as white, being the simple. The input is styled to have a large clickable area with padding and background color that changes when hovered. JavaScript functionality. First, the upload button. Now, as I've covered the basic CSS structure, you can see the HTML code here. It is basic PDF input where we'll input the PDF. This is upload the PDF. After choosing the PDF, we'll upload the PDF so that it can be sent to the backend. And this fetch button is used to fetch the frequencies from the backend. This is the spinner class that would be showed when the process is loading. That is, the backend has not sent the data yet and it's still loading. The output is shown in the frequency table. There would be two headings. First is the teacher, and the second is the load in hours. Load in hours is the amount of hours that the teacher has to work per week. Now, let's come to the JavaScript code. JavaScript code, first, we are clicking the upload button. The document.getElementID upload button is by which we are connecting to the upload button written here in the HTML code. Here we have added the event listener as click, and then we have written the function that handles the click. Here the const file input is where it is getting the PDF file that is being uploaded from the front end. Here the upload the PDF button is clicked. It checks if a file is selected from the input field. The selected file is added to the form data object, which is then sent via a post request to the backend API. As you can see, the backend API is mentioned here. It is running, the backend is running on localhost 7000, as you can see here, and we already discussed the /extract text endpoint through which it gives us the JSON response to the given PDF. While the data is being processed, a spinner would be loaded. The loading icon is displayed. Now, once the data is received, it updates the table with the frequency of characters or data from the PDF. As you can see, the table mentioned here, the data will be shown for two headings, teacher and the amount of hours they have to work. Here, we are connecting with the table, thus it would insert the data in the particular rows of the table. This is the catch. Then and catch are the ways where we can do the correction and error handling. In case there is an error while we are fetching from the backend, it would throw an error. Here we can see it in the console as the terminal. Finally, block is always executed whether we go to the then block or the catch block. Now, the second button is the fetch button. Again, the event listener is click, and we have defined the function here that would tell us the function that would be performed when the fetch button is clicked. The code, as you can see here, is given here. Now, explaining the code, when the fetch button is clicked, the front end sends a get request to the get frequencies endpoint. As you can see here, I've already explained the get frequencies back endpoint that has been written in the server code. The get frequency endpoint in the server code, that is the backend code, gets us the frequencies that has been extracted from the PDF. When the fetch button is clicked, the front end sends the get request to the /get frequencies endpoint. Upon receiving the data, the table is populated with the frequencies data, updating dynamically. Therefore, the conclusion, this code is combination of various web technologies to create an interactive page that allows users to upload PDF files, send them to server, and display results, that is the frequencies in the table. The code demonstrates how to work with modern APIs, handling user input, file uploads, while offering smooth visual feedback with Spinner, a responsive panel. Thank you so much for watching. I hope it was helpful.